Today's video, thank you for joining me by the way. Today's video we're gonna talk about threading. We're gonna cover the outside threads and inside threads. I'm gonna try to make it as easy as possible. Hopefully the audio is good. I'm changing an ND16 filter with polarizer, so I hope the screen is clearly visible. So let's go to one that I've created before. I'm gonna press OK, and I can make changes to obviously to this program. Since we're running the other one, I'm gonna do, so let's say we created a regular line that's 2 inches before, if you remember, and that was with the 250,000 chamfer. That was a video before, but maybe I don't know how else or how different I'm gonna start uploading these videos. Nevertheless, I'm gonna go and I'm gonna dump the facing. You know what? Maybe I'm gonna actually use it, and I'm gonna build a program on a 2-inch stock. So you have a line that had 2 inches and 20,000 diameter, and we cut it down to 2 inches, and that had a quarter chamfer. And instead of doing a quarter chamfer as a line with starting corner, we created a taper then into a line. But let me go and we're gonna erase that, and I'll make it super simple. Just call this as a 100 corner. Now I'm gonna go to the end, key, insert, OK. Now this is extending, it's continuing the program that I've done before, but all I wanted is a line. So I'm gonna go, and this is once you press here and you insert, it's gonna show you the line, like all the options, but I actually want to shape to the end. Once I press to the end, gonna finish it, and it's gonna automatically create a new unit. I'm gonna go to turning and then threads, and now you have an option: thread out, thread in, thread face, and thread back. So we're gonna go to thread out, and it's gonna ask you if you have a chamfer 60 or 45 degrees, and that has to do with how it exits. And how it exits, I don't know if you're gonna see it. It might exit on a 63 degrees, for example. That would be a 60, I think, in like, or 45. So there's a difference how it ends. Sometimes when you get a part thread, like it wants you to kind of gradually leave the part with the part versus it just come out. Also depends if you have a part. You have some sort of a relief or a groove in the back, so when you thread, you kind of thread up to here, and then you have a relief, so you can, let's say if you're screwing something, it will come all the way to the face, and so like, or if you have just a straight part and you're threading up to here and you're just ending in a kind of middle or whatever, like a shaft and whatnot. So as a chamfer for regular threads, I'm gonna put a 0. And just to kind of show you again, once you press it, this is the option. Chamfering, 60 degrees you press 2, 40 degrees you press 1, or no chamfering you press 0, okay? I'm gonna press 0, now lead, it's gonna tell you the thread lead. So the thread lead, it depends if you're doing millimeter matrix, so threads in millimeters, or if you're gonna do like a, let's say UN, which is like the American standard. Let's say we're gonna go with number 8. So the way you do it is you press 1, divided by 8, how many threads you have, equals to, and this is gonna be your pitch. So your pitch is going to be 125,000, and number 8, that means you're going to have 8 of these of these threads per square inch. So if you have a 16 into 1 divided by 16 equals, and that's going to be your pitch. But we're gonna go with number 8. For example, millimeters, you're gonna have a 24 by 2.5, for example. So 24 divided by 25.4. So all millimeters are divided by 25.4 equals to, so 944.8. That's gonna be your outside diameter. And if you have a 2 millimeter thread, you go, let's say 2 divided by 25.4 equals to, and this is going to be your pitch, 78,007 tenths, okay? So this is how you do millimeters, or you have to convert millimeters pretty much to inches. Okay, so lead, we're going to go with 125,000, okay? And let me bring this calculator here. So this you got 125 input. Now it's going to ask for the angle. The angle on a Mazatrol, for example, if you press angle 0 and this is your thread, and let's say I got our parts back and I need to go a little bit deeper, I'm gonna put angle thread 0 and I'm gonna lower my offset till my tool is almost right in the middle, okay? So it will continue cutting threads like this. If you're gonna give it an angle of 60, for example, it's gonna start cutting like this, okay, under an angle, instead of going deeper and deeper and deeper. That's supposed to relieve some pressure or load from the tooling. So I usually go with an angle anywhere 50 to 55. So let's call it 50. Number of entrances. So this is a very tricky number. So sometimes you have threads, they have 3, 4 entrances. And though, when that happens, and let's say you have a nut, it will go in really, really, really quick. Really, like if you have 2 entrances, it's gonna screw in 2 times faster, 3 times faster, 4 times faster. So for example, the way you actually do that, if you have 125,000, so number 8, you actually have to, if you have 2 entrances, you have to program it as a number 4. So your lead is not gonna be 1 inch. It's not going to be 125,000. You have to program it as a 250,000, because what these entrances do is they take your lead and they're going to divide it by how many entrances you're doing. And the thing is, like, it actually threads really, really quick because it jumps. How to kind of explain is, you have 1 first entrance, 2 entrances, 3, 4. 1, 2, 3, 4. Okay. So technically, first entrance 125, then this will be 125, and then it goes back, and it's so you have to adjust a little bit differently. But like, if you do 4 entrances, everything has to pretty much. 2 entrances, you have to double everything. 3 entrances, you have to triple everything. 4 entrances, you have to quadruple everything, and so on and so forth. Okay, now as number of entrances, so we only doing 1, which is it's gonna be height. This is where it's this is a really good option. Usually the machine's always right. It's gonna ask you for the thread height. Okay, you just press auto set. This is should be 80,000, and you see 80,000. If we had a thread of 0.0625, we go to the height. Go to auto set, 40,000. So Mazak is very, very good when it comes to the Mazatrol to give you that, you know, what did I do? To give you that actually automatic depth finish. Now you have a thread out, you have a pattern. So you have a standard. So for example, standard, it's going to ask you how many passes you want to do. So let's say for number 8, we can do 12. Okay. If you go on the pattern, it's gonna, on number 1, it's gonna give you consist of depth. So for example, you can go 2,000 depth of cut. It's gonna divide the amount of passes per 2,000. Okay. Let me see what other patterns we have. So we have, then you have a consistent area. From what I remember, consistent area, what it does. I've used that for big threads, like quarter-inch deep threads. And what it does is the initial depths of cut are gonna be a little bit bigger, and once it's gonna start getting deeper, it's gonna get smaller and smaller and smaller. So like at the end, you're literally cutting barely anything. This is a really good for really big threads, okay? Where like at the bottom, you know, you're already putting so much stress on your tooling, especially if you're doing internal threads. So like this is a really good option. But for number 8, 0 is fine. If you're doing long shafts and whatnot, sometimes 1 is fine too, because you can control the depth of cut. So how many passes? You can do auto set. So auto set is going to be 14 passes. Then your surface speed, let's call it 300. Okay, and now starting point X, starting point Z, final point X, and final point Z. Okay, starting point X is going to be 2 inches, 0, going 2 inches, and then we, let's say we turn to 3 inches, so 3 inches, right? Program, toolpath, part. Okay, let's go 0.8, part. Okay, so this is our thread. Now, you can actually do a taper. So let's say if you got a taper on the machine, or your machine pulls a taper, you can go from 2 inches to, let's say, 210,000, for example, to 3 inches and whatnot. Now, usually, and that depends on the type of jobs you do, but sometimes, let's say if you have a 2-inch thread, your diameter, outside diameter, it's going to be a little bit less than 2 inches. For example, 1 inch and 990, okay? So you give yourself a little bit of room. And when it comes to the chamfering, for example, so as we see, the height of this thread is 80. The height or the depth of this thread is 80,000. So for example, you could do 90,000 corner, unless you have a crappy insert and you actually have to go deeper for your wires or thread to go in, then, you know, then 100, let me see, then 100, you know, it's gonna be fine. When it comes to internal bars, internal threads work a little bit differently. Okay, insert, okay, turning, thread, inside, chamfer 0, lead 125,000, angle 50, how many entrances? 1, hot, auto set, thread. So I don't have any tools right now, but same thing, pattern, you know, the number of passes, let's go 16, 300 surface speed, MA for coolant, starting, let me dump this one out. Okay, so thread in. So now you have to remember, when it comes to thread external, as we see, this is our bar. This is gonna be thread, external thread. This is 2 inches. This is gonna be a 2-inch thread. Oh, sorry. Now, when it comes to internal threads, let's say, let's do a bar. Okay. This is gonna be our ID. Okay. So this is your thread. Let's say the top or the bottom of the thread, when you actually, if you say it, is gonna be 2 inches. So that means that hole has to be smaller. And if you're, for example, if it's 2 inches and you have an 80,000 depth of depth of thread per side, which is 160. So that means 2 inches, that would be 1 inch and 840,000. But it's actually not. It's somewhere kind of in between. So sometimes it's kind of good to actually look up the data, and you're gonna see a tolerance. What will be your like ideal opening for the number 2 thread? I forgot from top of my head. Like for number 8, so number, thread 16, same thing as in millimeters. They're all gonna be a little bit different, but the 2-inch thread on ID is gonna be right here, and same thing as the 2-inch for OD. Also, it's gonna be the actually OD stock. So the OD stock usually sometimes it's a little bit smaller than the thread, and ID, like I said, ID it's gonna be the bottom of the thread. It's always gonna be much smaller, and this is pretty much 2 inches where it should be, right on the, like it's gonna be right at the root, how they call it, of the actual thread. Now, one more thing that we can use the threading cycle for. For example, you can have a bar, okay, and sometimes you have a, let me see, you might have a spiral, right? Okay, so the way you actually do spirals, let's call it, you might have so 2 inches in diameter, spiral is gonna be 1/2 inch pitch, it's gonna say, and 30,000 depth, and it could be squared or it could be a radius. And the way I do it is, for example, it has a radius, 1/2 inch pitch, and 30,000 depth per side. Okay. So, okay, so we have a. I'm gonna dump this, and this works for also for inside like oil grooves and stuff like that. You program them as a thread. So thread out, chamfer 0. Your lead is gonna be 0.5. That's gonna give you 1/2 inch. It's gonna give you two spirals per inch. Angle, I'm gonna press 0. So I want this to be go even, not under angle, because now we're using a radius insert. Number of inches is 1, and height. If you got a 1/2 inch lead, and you're gonna go to the height, okay, and I'm gonna go to auto set. The height is gonna be 320,000, but actually it calls for 30 inches. So you just put in 30 inches manually. Now you have a 1/2 inch lead, 30,000. You take your, for example, you might have a radius. It's gonna call it for 62,000 wide and 31,000 31,000 radius. It's actually it's not gonna be actually 62, but as an idea. So you take a insert like that, let's say top notch, you put in the machine, you're gonna set it, and you're gonna teach it as a regular threading insert, even though you know it's not, it's a grooving, but still you set it because it's gonna work, or it's gonna function like a thread. And you program this, like I said, your lead, so whatever lead is going to be on your spiral, your height, numbers of how many passes, you can do 20, speed and stuff, and then you just kind of run it, like I said, you just run it like a, you're going to run it just like a thread. And it's same thing when it comes for the inside. So inside, for example, 2 inches. So we have it 2 inches on the inside, and let's say it's got a 30,000 per side, which is going to be 60,000 off of diameter. So I would go and program this erase. Okay, I'm going to insert shape end, turning, thread in, 0.5 for lead, 0 for angle, multiple entrance 1, height 30,000, oops, from 0 to 30. Okay, thread is gonna be, let's say thread in, pattern, I do consistent depth, let's say of 2000 for example, speed 200, M8 for coolant, starting point X, 0.0, 2 inches and 60 to 0, 2 inches and 60 to 3 inches. Now 2 inches, 2 inches and 60,000 is gonna be the top or the root of that grooving. So that means if you say that you have a 30,000 height, which is gonna be per side, it's gonna start exactly at 2 inches where your material is, and it's gonna keep creating that spiral deeper and deeper till it hits 30,000 per side, which comes out to 2 inches and 60,000. So that's how you do your spirals and your threads, or like anything pretty much that kind of it looks like a thread, or like a from thread families and whatnot. All right, guys. Well, that would be it for today's video. Thank you for watching, and next time.